Good evening. I had several people tonight that missed the lecture on disc brakes, so I thought I would sit down this evening and re-record that lecture so that those of you that missed it would have the opportunity to view that. Disc brakes is kind of at the heart of what we're doing in this class, so it's very important. So what I'll do is tonight I'll just pick up with the beginning of disc brakes and go along here to the point that we shut lecture off this evening. And I know that part of the first part of this will be a review for some of you, but just jump in wherever you need to, and we'll go from there. By way of introduction, on disc brakes, I just start off by saying that almost everything out there now has at least front disc brakes. Most vehicles have four-wheel disc brakes, but everything you see, you're going to see it's very common. That's what's out there now. So that's what we need to be familiar with. Disc brakes create braking power by forcing flat friction disc against the sides of a rotating disc. And we've talked about most of this stuff. So again, some of this will be a review. But the disc is also called a disc brake rotor or rotor. It's bolted to the wheel. Actually, the wheel bolts to the hub through the rotor, and then the disc brake calipers straddle the whole assembly, and the pads are on the inside of it. Hydraulic pressure from the master cylinder causes the caliper to create a mechanical clamping action, forcing the brake pads into the surface of the rotor, creating friction. So again, we're clamping brake pads against the rotor, and that's how we're creating our friction that's going to slow the vehicle down. As the vehicle's kinetic energy is transformed into heat energy, the vehicle's speed decreases. So as we transfer this kinetic energy into heat, we're slowing down. The brakes are working. Primary components, we're going to look at three components: the brake rotor, the brake caliper, and the brake pads. The rotors are the main rotating part of this brake system. So the rotors have to be very durable and resistant to damage by high operating temperatures. So these things have a lot of hot and cold cycles. They get really, really hot. They have to perform well even under those temperatures, or they have to perform well in cold temperatures. They have to remain straight and true so they don't shimmy and vibrate. So a very important part of the disc brake system is the brake rotor. The caliper straddles the rotor and houses the disc brake pads and an activating piston or pistons. They use hydraulic pressure from the master cylinder to apply the brake pads. The disc brake pads are located inside the caliper or the caliper mounting bracket, and the pads are forced against the rotor to slow or stop the vehicle. So again, we're using hydraulic pressure from the master cylinder to move a piston in the brake caliper, and that piston will clamp the brake pads to the rotor and slow us down. When the brake pedal is depressed, push rod transfers the force through a booster to a hydraulic master cylinder. That master cylinder converts the pedal force into hydraulic pressure. The pistons operate on friction pads to provide a clamping force on a rotor attached to the wheel hub. So the pistons are going to push these friction pads against the rotors. It's what we've been talking about. The rotors are free to rotate with the wheels because the wheel bearings and hubs that contain them, and we'll talk about wheel bearings later. Here's kind of the assembly, the way it works, and of course, obviously, we're stepping on the brake pedal here, and our brake pedal linkage is going to push this push rod into the master cylinder. It's where our hydraulic pressure is going to come from. That hydraulic pressure is going to go to the brake calipers. It's going to clamp on the rotors. Guys, here's two different types of rotor. If you look at that, this is a hub style rotor that's got wheel bearings. It's the ones we talked about that you have to pack grease into the bearing and all of that. And we'll certainly be doing that in class in the lab. So, but this is a hub style rotor. This is a hubless rotor that basically just slides over the hub. The lug studs come through it, and that's what retains it in place is when you tighten the lug nuts down. Talking about brake calipers here, talking about floating or sliding caliper mounting methods, and we'll talk some about that here in just a second. Sometimes on independent rear suspension cars, some sports cars and stuff, Corvettes, they have what's called inboard disc brakes, and that just means that it has most of the same components, but they're just in next to the rear axle housing, in closer to the axle housing. That has to do with suspension, what's called sprung and unsprung weight. It has to do with the handling characteristics of the car, so they mount them in there at the axle housing. So the calipers are mounted on or next to the differential, and it increases vehicle handling. Disc brake pads require much higher application force to operate than drum brakes. So we take a lot more force to work on with these disc brakes than we do drums. And the way we get that is by using pistons with larger diameter. Remember that when we talked about Pascal's law, that every place that we check within a hydraulic system, in a closed system, the pressure is going to be the same. So the way we get more clamping pressure is by increasing the diameter of the pistons. Advantages and disadvantages to disc brakes over drum brakes. Biggest advantage is they cool better. You know, we talked about we use friction to slow the vehicle, and friction creates heat. And the better we can dissipate and remove that heat, the more effective our braking system is going to be. So cooling is far more rapid than a drum brake. It's better suited for high performance driving or heavy duty vehicles. Rotors tend to scrape off water more effectively. So, you know, we talked about water fade on drum brakes. You drive through some water or a mud hole or something, and you get water between your brake linings and your brake drum on a drum brake. You're going to have brake fade. You're not going to have very good braking performance. But you know, think about a disc brake system with that pad setting right against the rotor. As that rotor's turning, that pad is going to be skimming that water off of the rotor, so you're not going to have that issue. So, disc brakes, because of the way they're designed, they don't need any adjusting. They're self-adjusting, because remember we talked about as the brake pads wear, the position of the piston changes. It stays out of the caliper further to take up that space, so there's no adjustment needed. And they're much easier to work on than drum brakes. Disc brakes are far easier to service than drum brakes. Disadvantages is they're prone to make noise. They squeak, clunk, grind, clank. They have a bunch of different noise issues. And the rotors tend to warp easily. If we overheat these rotors or do a poor job of torquing the wheels on the vehicle or something like that, it can cause those rotors to warp, and then we're going to have a brake shimmy or a shudder. Very small thickness variations can cause brake pulsations, requiring resurfacing or replacement. Not self-energizing and need higher clamping forces. Again, we get those higher clamping forces by using bigger pistons, and it's harder to come up with an effective park brake system with disc brakes than it is drums. With drums, it's very simple. They just add a cable and basically one lever and an arm, and they've got a park brake. With drum brakes. With disc brakes, it's, as we'll see here moving along, it's a little bit more difficult than that. As we talk about brake calipers, we're going to talk about two main styles: fixed calipers and either sliding or floating calipers. And we'll see the differences between those here in a minute. All calipers are fitted with a bleeder screw. Fixed calipers are rigidly bolted in place and commonly have 1 to 4 pistons on each side of the rotor. Hydraulic pressure forces the pistons on both sides of the rotor inward. So with a fixed set of calipers, the caliper is bolted solid. It doesn't move, and it's got a piston on each side of the rotor, at least one piston on each side of the rotor, and each of those pistons presses the brake pads in and clamps the rotor and gives us our stopping action. So here is a fixed mounted caliper. We've got 2 pistons. We've got hydraulic pressure coming through this line, and by applying this piston, come over and applying this piston. So it's going to push those brake pads into that rotor, and it's going to clamp those in place, and we're going to get stopping action because we're putting these friction surfaces against this rotor and clamping it. The sliding style is a little different. Hydraulic force is generated on one side of the rotor. These tend to have one piston. They just have one piston they have a piston on one side only. So what happens is they've got pins and bushings. As this piston applies its brake pad against the rotor. When it does that, this caliper is free to float back and forth. When this comes up and clamps this rotor, this caliper is going to slide over, and this other pad is going to be against it also. They're going to the pressures are going to equalize between these, and because even though we've only got one piston, we're going to have equal pressure on both sides of this rotor. So that's because this is free to float or slide. Now, and this is a floating style. It floats on these pins. So anytime you service the brakes or brake pads, you're going to make darn sure that these pins and stuff are serviced and clean and operating well. This is the pins allow the caliper to float in and out as the brakes are operated and the brake pads wear. A sliding style, which is a lot like a floating style. A sliding style is going to have these machine surfaces here. This is the caliper, but on the caliper bracket where this sets, it's going to have a matched sliding surface that are going to set together, and this caliper is going to slide back and forth on those surfaces. Now, on this particular one, this is what retains the caliper and keeps it in the bracket. You'll notice this little channel here, a little wedge-shaped channel. The caliper bracket will have a matching one. And this pin, it's got rubber on the inside of it. It squeezes together to start it in there. And that's what retains it. That's what keeps it from coming off. Again, several methods to hold them. This one's very common. Ford used a lot of these types of pins here. O-rings. And disc brake calipers, the piston is sealed by a stationary square section sealing ring called a square cut O-ring. The O-ring is compressed between the piston and caliper housing, creates a positive seal to keep the high pressure brake fluid from leaking out, prevents air from being drawn into the system when the brake pedal is quickly released. Low drag calipers are designed to maintain a larger pad to rotor clearance. So let me see, I think somewhere here I have got a animation of that. Maybe it's this one. Yeah. Guys, here's this seal. Here's this little square cut seal. This is the inside bore of the brake caliper. This would be the piston. When we apply the brakes, what's the deflection in this seal? Now we release the brakes, and there's applying the brakes. So what happens as this piston comes out to apply the brakes, it tries to drag that seal with it. When it does, it distorts it. And it's kind of like a bungee cord. When the brake pressure is released, that a bungee cord is going to go back to its original position. So does this. And when it does, it pulls that piston back in a little bit with it. So it pulls that piston away from the rotor and gives us some clearance between these brake pads and the rotor. So that seal is responsible for doing that. Now, some vehicles use some springs that are mounted on the side of the brake pads, which do the same thing. But this, generally speaking, this seal is what's responsible for doing that. And again, here's what it looks like. This is the inside of the caliper bore here, and here's this square cut O-ring. So when that piston is in there, and we apply that piston by putting pressure on it, this little O-ring deflects a little bit. When the pressure goes away and this piston seal straightens out, and goes back to its original position, it pulls that piston back in a little bit with it. And here it shows it being in the deflected position or the twisted position. So when we release hydraulic pressure and this straightens back out, it's going to pull this piston back a little bit and give us clearance between the rotor and the brake pad. Now remember, when we have clearance between the brake rotor and the brake pad, when we step on the brake, we've got to take up that clearance. So we've got to get that brake pad pushed up against that rotor before we start to get any braking. So what we use is what's called a quick take up or a quick fill master cylinder. It uses a master cylinder that's got a big bore right in the very beginning, just to get that piston moving in a hurry so that it gets out against the rotor. And then it goes back to its normal size and we have the regular pressures. But if we didn't have this quick take up master cylinder, we would have a really low brake pedal position when we stepped on it the first time, because we would use most of our pedal application just to push the piston back out to its original position before it started clamping on the rotor. So this quick take up master cylinder pushes those out there in a hurry so that we have a good solid brake pedal. Pistons are made of a phenolic resin. It's kind of a hard plastic. They transfer heat more slowly than steel. and they're less susceptible to brake failure from boiling brake fluid. And we've got a dust boot on the outside of the piston to keep moisture and dirt and stuff from getting inside of the caliper bore. Here's one that dust boot has obviously failed, and we've got a bunch of crud and rust and stuff inside this caliper. I don't know if that one would be rebuildable or not, but anyway, that's one that's obviously needs some attention. Here's the different types of pistons. This is one of the phenolic, or I call them plastic, but that's one of it. And here's one of the steel ones. Now, there was a time when they used stainless steel pistons in most of these brake calipers. And when they used the stainless steel, you very seldom had to replace that piston when you rebuild a caliper. Now you replace the piston. If you're going to rebuild them, you're probably going to replace the piston every time you rebuild the caliper. It gets to the point where the cost of the piston, the cost of the seal package, the time involved in honing all of this and cleaning it all up, it's not hardly worth rebuilding anymore. It's almost more cost effective just to buy calipers already rebuilt. And that depends on the application, depends on your customer and what you're working on. But a lot of times anymore, what I do personally is I just replace the brake calipers rather than trying to rebuild them. It takes a lot of time to do that, and time is money. Pads, talk about pads a little bit. They consist of friction material bonded or riveted to a steel backing plate. Bonded linings are less expensive to build, and the bonding agent can fail under high temperatures sometimes. Riveted linings are used on heavier duty or high performance vehicles. And this is the metal rivets provide a mechanical connection to hold the lining to the backing plate. So here's a bonded lining where it's the lining, the friction lining is glued to the steel backing. It's got a glue type stuff that holds it there. Here's some that are riveted. You see the rivets through here. Now notice that the riveted ones, they say, are more high performance because they don't. This glue can give up. This bonding agent can give up, and the pads come loose, where the rivets obviously won't. One of the advantages to the bonded is these rivets are pretty thick. So this brake pad, when you have to replace it, when it gets down close to the rivets, actually with a bonded lining, you would still have some brake lining left that you could go ahead and use. So that would be the advantage to the bonded. And I see a lot of both. I think probably more bonded now than riveted, but you see some of both. Now you see here on the side of this caliper, you see these, they call them brake pad locating lugs on the end of the pad here to keep it to locate it within the caliper or caliper bracket. So the backing plate had lugs that correctly position the pad in the caliper assembly and help the backing plate maintain the proper position to the rotor. Friction material composition affects brake operation. Materials that maintain a stable friction coefficient over a wide temperature range generally require higher pedal pressures. Guys, here's one that the brake rotor obviously has got a lot of wear on it. I'll just tell you from my experience at City Utilities, we have a bunch of Dodge Sprinter vans. They're made by Mercedes, and those things would they're pretty heavy. They're loaded with meters and pipes and fittings and stuff like that we used up there. And so they were pretty heavy. They were kind of hard to stop. And we ended up using a performance friction carbon metallic brake pad, and it really helped the stopping of the car, of the van. It was much more effective than the stock brake linings were. But every time we took them, had to replace the brake pads, our rotors looked like this. We had to replace the rotors also because they were extremely hard on the rotors. So anytime we replaced brake pads on those, we replaced the pads and rotors as a pair. The amount of friction between two surfaces is expressed as a ratio. It's called a coefficient of friction. This is the kinetic energy of the sliding surfaces and converted into thermal energy. Disc pads and drum brake linings are made from materials that have moderate coefficient of friction. Brake failure occurs when the stopping power of the brake pad is reduced. Brake friction materials historically made from asbestos compounds. Asbestos is generally banned nowadays due to its hazardous nature. Guys, asbestos was an awesome product. back in the day. They used it a lot on clutch discs and a lot on brake linings. And man, it worked good. It really was a very good temperature resistant material. It wore very well. And they used it for a long time. But they found out, man, it was a terrible, terrible hazard as far as cancer causing and stuff like that. So they rightfully banned it. But man, we used to use that stuff a lot back several years ago. But again, like I say, they found out that it was a hazardous, certainly a hazardous material, and they got rid of it. There's not any of it out there now that I know of, very, very little. But so now we use some organic materials, low metallic materials, semi-metallic materials, and ceramic materials. What we're using on our brake pads now. And here's some different coefficients of friction that we'll talk about. Brake composition for any vehicle or used as a combination of weighted qualities such as, again, things we're going to consider when we're choosing brake pads: stopping power, heat absorption and dispersion, resistance to fade, recovery from fade, the wear rate, performance when wet, operating noise, price. There's a lot of things, noise. There's a lot of things that are going to come into play here when we're trying to make those determinations. And here again is some codes. Guys, when you see this letter designation on the outside of these brake pads, that's going to have to do with its coefficient of friction. Guys, I think of that as like the tire rating on the sidewall of a tire, where we have like a speed rating and a wear rating and that type of thing. It's kind of the same type of a thing. So just remember that's on there, you know. And what I do generally is I buy a middle of the road product. I buy always a name brand. When I'm dealing with brakes, I always buy name brand stuff. I buy either Wagner, Raybestos, or Ice, or something like a good name brand of product when I'm working on brakes. And I think you'll be well served to do that. One of the big problems with brakes is noise. Brake squealing is caused by vibrations between the pad and the rotor. Some of the ways that they can address that is they use softer linings. Sometimes can do that and reduce that vibration. There's some shims and guides that you can put in the brake pads. Guys, if they don't have room to vibrate, if they fit in the caliper and the caliper bracket tight where they can't vibrate, then we're going to do away with this brake squeal and brake noise that we get. Some of them use springs to hold them in place really tight. Some of them contour and groove the lining material, and some of them have bendable tangs, and I'll show you a picture of some of those here in a minute. Here is a brake hardware package. Normally comes when you buy a set of brake pads, it's going to come with new hardware, and this hardware is going to go down in the a lot of times set in the caliper. You take the old one off and you put the new one in, and a lot of times this is the area where the brake pad, when it moves, slides back and forth, and there's a wear pattern established there. So when you get these new hardware packages, use them. Don't throw them away. A lot of people don't change those unless the other ones just look terrible. They just leave the other ones in there and put new pads on it. Change this stuff. That's why they give it to you. If you go over here and look at this, this looks like a 03 to 05 maybe Ford pickup rear brake caliper. These little tangs that are made on this brake pad are spring loaded. You have to kind of use a screwdriver or something to hold them out so you can put the brake pad on, and then they snap back in place and they hold that pad tight against the caliper and keep some of that vibration from happening there. That's one way of doing it. Here's another one. If you'll notice this little piece on the end, this is spring loaded. You have to squeeze it together and put this in its caliper bracket, and then it extends out and it takes up slack so that there's no place for that to vibrate. Also notice this has a slot cut in it that can help also. Then you look at this one here. This, guys, has a brake pad that's got a little tang on the top of it. You see how that little tang is bent flat down against the brake caliper. Well, it didn't come that way. When they come out of the box, this is sticking way up in the air. And so that if you didn't go in there and make this adjustment, it would flop back and forth when you stepped and released the brakes. But when you take a pair, like he's using channel locks here, and squeeze that down and lock that into that caliper, it makes it fit tight where where that pad can't move around, and that really helps with the noise aspect. Talk about wear indicators, something to let you know that your brake pads are starting to get thin. We got a couple of different types. This is a brake lining indicators used to notify the driver that the brake pads are worn to their maximum limit. Excessively thin linings tend to heat up quickly. Here's one type, the most common type because it's the cheapest type. Just a little piece of metal that's riveted onto the brake pad so that you notice this pad is getting really thin. Because it's thin, this little, they call it a scratcher here. This little scratcher is rubbing against the rotor. And when this pad was new and it was thicker, the pad was way back here, and that scratcher would be sitting way over here. It'd be a long ways away from this rotor. But as it wears and this is moved in, eventually this little scratcher got against the rotor. And that will make a really obnoxious squealing sound that will get your attention and let you know that, hey, those brake pads are getting thin. They're going to need some attention really soon. Well, that's one type of wear indicator. The other one is an electric one that'll turn on a light on the dash. Now, this isn't the same light that we talked about in hydraulics that comes on when we have low brake fluid or you know, a park brake that's applied or something like that. This is a different light, and it's a light that tells us that our pads are getting thin. The way this light works is this. We have a circuit here. Here's our light that comes on the dash. We turn on the key. We have voltage going to this light, but it has no ground. So we don't have a circuit. The light's off. Made inside this brake lining, there is a little contact. It's got a wire that comes off to it that goes over to the other side of this bulb. Whenever this wears thin enough that this contact is touching the brake rotor, it makes a ground for this circuit. Now we have a ground. We have a completed circuit, and the bulb will come on. So that little contact, whenever the brake pad wears down enough that little contact contacts the rotor, then we have the light come on. That's our other type of a warning device that tells us that our brake pad is getting thin. Now, this little contact, it's not always made in the brake pad, but if not, it's going to mount to the brake pad and it's still going to do the same job. Brake rotors. Again, they rotate with the wheel, usually made of cast iron, but they're starting to use some composites now to reduce weight and to dissipate heat well. Any unevenness in this rotor will cause a brake pulsation or a brake shimmy. And the way we check those, if you remember, we've done this in the lab, we take a micrometer. We check this for parallelism, which means we're going to go around this rotor and in several different spots and make sure that the rotor thickness is consistent all the way around the rotor. If not, it's going to cause a pulsation. And then we're going to check for lateral runout. Remember, our dial indicator measures movement. So we're going to mount a dial indicator to this and rotate that rotor and watch the dial indicator, see how much runout we have. There's a spec for that. And if we have too much runout, again, it'll cause a brake shimmy or a brake pulsation. So those are two of the checks that we're going to do on our brake rotors. Rotors must maintain their shape and resist warpage under high heat and pressure conditions. And we talked quite a little bit about that. And they have a dust shield that's mounted behind the rotor. And it keeps rain and slush and crud and mud and stuff from splashing up on the rotor. Also, it helps direct the air around that rotor to cool it. So it's very important component. And one thing about this shield, they're really bad to get rocks in between this shield and the brake rotor. And it sounds a whole lot like our brake warning sensor. They really squeal and grind when they get a rock in there. That's pretty common. It's really easy to take a screwdriver and push it out. You know, we talked about rotors from the standpoint of rotors that have a hub on them and then the hubless style rotor. We're also going to talk about solid rotors and vented rotors. Solid rotors here are, again, they're cheaper. They don't work as well as the vented rotors. Vented rotors have air, centrifugal forces air through these vents to help cool this rotor. They're used to improve the heat transfer to the atmosphere. Passageways are designed to use centrifugal force to cause airflow. So centrifugal force pushes air through these little vents and helps cool the rotor. Now, some of these are directional. If you notice this rotor here, the little fins on the inside of this are directional. So there'll be a left side rotor and a right side rotor. If you put them on the wrong side, they're not going to move air properly, and that rotor is going to overheat. So if the left and right side have different part numbers, you need to make darn sure you get the right one on the right side, or you're going to have problems with it. If they've got these slots and holes drilled and stuff like that, again, that's to help with heat transfer. And you'll see that on most high dollar rotors, especially, you'll see a lot of that type of stuff. And most brake rotors are stamped with the manufacturer's minimum thickness specification. And here it is right here on this is a solid rotor, of course, and right here on the outside of it, minimum thickness is 9.5 millimeters. Now that's pretty easy on this one to see because this is a new rotor. But when this has got a lot of rust and crud and corrosion and stuff on it, that might be harder to find. Also, it may not be right here on the outside of the rotor. It may be stamped down inside here somewhere. So if you can't find it right away, there'll be a spec for it in your shop manual to the minimum of that this rotor thickness can be and still operate. And here's what we're talking about with that. Here's a rotor that is full thickness. This rotor hasn't been machined or worn out. It's a full thickness. So it talks about at the end of a moderate hill, this rotor is only at 400 degrees. Well, here's one that's thinner, and it's at 500 degrees because, again, it's got less metal here, so its ability to dissipate heat is lessened. So I replace a lot of rotors, and the reason is, if the reason this rotor warped in the first place is because of heat, and so to straighten it out, we put it on a machine and we remove metal from it. So now that it doesn't have any run out again, but also we have lessened its ability to dissipate heat. So now we're putting this rotor back on where this one has already warped. And then we have one that's got less ability to dissipate heat. So when I run into a situation like that, I'm all for replacing the rotor. Parking brakes. Again, remember, they're not emergency brakes. They're not designed to be an emergency brake. They're designed to hold the vehicle stationary when parked. Must be separately activated from the service brake. Can be foot or hand operated. Remember our service brake. Our service brakes are just our regular brakes that are operated by our brake pedal. Okay, they're hydraulic. We use hydraulic pressure to apply a brake shoe, a set of brake shoes, or clamp a set of brake pads. But our parking brake is separate. It's going to be mechanically applied, not hydraulic. So it's going to have cables or linkage or something like that is going to apply this. And again, it can be hand operated, foot operated, or electric operated. We'll see here in a bit. It says most of them are mechanically applied by use of a cable and ratcheting lever assembly, either from a pedal or from a hand lever. Primarily two types. We're going to talk about two types of parking brakes: integrated parking brake caliper and a top hat style. So we'll talk about those as we go along here. Electric parking brakes are used in some vehicles. Guys, one of the reasons they went to electric vehicles, at least what I've been told, is that up under these dashes, they got so much stuff under there now, they're running out of space. And so they can use these electric parking brakes, and they don't take nearly as much space up under that dash, and so that's what they're using, and we'll see how they work here in a minute. The integrated mechanical parking brake calipers. Guys, these are a little bit complicated in design. They're not really complicated to work on, but a little bit complicated in their design. What they've got is this. Again, we've got a cable, and this cable is going to come from either the pedal or from your hand lever. When we pull that cable, when this cable pulls in this direction, it's going to move a lever. Right here is a lever. That lever is attached to this threaded shaft. Now, our brake piston inside the caliper is two-part. So when we rotate this shaft, it's going to thread itself up and push this piston against the caliper to apply the park brake. When we release the cable, the spring is going to return it to its stock position. And that's the way it works. So again, we pull the cable, it moves this shaft, which is threaded. That's going to thread this piston, the inside of this piston basically out. and apply that brake pad. So it says a lever on the back side of the caliper is pulled by the parking brake cable. The lever converts that motion into rotary motion on a shaft that enters the rear of the brake caliper. That's right here. As the shaft is turned by the parking brake lever, the nut causes the piston to be forced outward, applying the brakes. Releasing the parking brake cable allows a spring to unwind the shaft and release the pressure on the brake pads. So that's the integrated mechanical style. The other one is called a top hat style. The reason for that is because the rotor itself looks like an old top hat. It has a deeper offset than normal. So here's our brake rotor. This is the inside of our brake rotor. Right here is the surface where our brake pads ride. But on the inside of this rotor, if you'll notice, we have a brake drum made inside here. That brake drum slides right over these brake shoes. These brake shoes are applied by a cable from the park brake. So in other words, when we step on that park brake, it's going to take and move these shoes outward by a cable, and it's going to apply them against this drum, and that's going to hold us in place. That's going to be our park brake. So again, the top hat design and the integrated mechanical park brake. That's two different park brakes that we're going to use with rear disc brakes. Talk some about electric parking brakes. Again, pretty simple. They have a motor that's attached to the caliper, and there's a wedge on this motor. So what happens very simply is when we turn them on, there's a button on the dash, and we turn on the park brake. When we do, this little wedge is forced upward, and when it does, it moves this piston in and clamps it against the rotor to give us our park brake. When we release it, the wedge moves out, and the spring returns it, and off we go. So just got, again, electric motor with a wedge that moves this piston in and out, and that's the way our electric park brake works. When we go to release it, guys, it can be released. Some of them have, you touch the button and it releases it. Some of them, it says it can be integrated with the controller area network or CAN bus system to provide additional features. CAN bus is something you're going to become very familiar with as you work in this industry. It's the car's ability for the different computers to share information. We can have one sensor that can be looked at by several different systems, and the CAN bus is how that information is shared. So on this particular one, say we have our park brake applied, we step on the brake and we pull the car out of park and put it in drive, it would automatically release the park brake at that time. Servicing disc brakes. We'll talk a little bit about servicing disc brakes. We're not going to go a whole lot further here before we shut this down for the night, but guys, understand the customer's concern. Read the service advisor's notes on the repair order carefully. In your career as an auto tech, you're going to have to train probably several service advisors. What the service advisor, guys, has got to do is they're the ones, he or she is going to meet the customer at the door. They're going to write down the customer's concern for you. So they come in the door, the customer says, hey, I've got a brake squeak, or I've got a brake noise. And if that's what your service writer writes down and gives you that ticket, that's not a whole lot of information to work with. You need to train your service advisor to get you some information. Ask questions. Does it do it when it's hot? Does it do it at slow speed, at high speed? Does it do it when it's wet? When are you hearing this noise? Exactly what kind of a noise are we talking about? It can help you tremendously when you get some information to work with. It says here to test drive to verify the accuracy of the concern. Find a safe place to operate the brakes at a variety of speeds and a variety of pedal pressures. So it's good to have the customer come along on a test drive. And that's right, it is. And the reason for that is the customer knows what their problem is. They know what they want fixed. They know if it's a noise, they know what noise they're hearing that they want to go away. I'll just tell you this, my experience has been test drives with a customer are a pain. And it's because you end up talking about everything but the problem. They want to know, why their car does this. And hey, when we get back, would you take a look at this for me? All different kinds of stuff. But if you can get some information from the customer for what they want fixed, then that makes it a good thing. Because remember, at the end of the day, they're the ones that sign the check. So they're the ones that have to be happy. Extreme caution is required for a test drive with a concern related to an analog brake system. Guys, anything with brakes, if you're going to go test drive it for a brake concern, be very careful. It says if you're going to test the ABS system, it's helpful on a surface with limited traction. So if you've got an area that's wet, that you can slide the car a little easier to test the ABS system, that would be preferable. ABS activation can typically be felt as pulsations in the brake pedal and possibly the steering wheel. We've all felt that. You know, you get on icy roads or something, and you start to slide, and you can feel the brake pedal moving your foot. And the reason it does that, and we're going to study ABS down the road in this class a few weeks, but what it's doing is it's applying and releasing the brake very rapidly. And think about how much steering control do you have when you're sliding? You have zero steering control. But if you let up off the brake, you do have some steering control. Well, that's what happens with ABS. As it applies and releases the brake, when it's released, you do have some steering input. So it can be very helpful for that. And also, you know, when it applies the brake, when your brake is sliding and it releases it and then reapplies it, there's a chance that it will grip better. So ABS is a good thing, and most everything out there has ABS now. Sometimes, guys, suspension and steering faults, tire faults, different things like that can appear to be brake problems. The example it gives here is the strut rod bushings on the suspension system are worn, then braking the vehicle will cause the wheel to move rearward. Some suspension systems where the lower A-frame or the lower control arm mounts to the frame, it has a single mounting point. And because it has a single mounting point, that control arm tends to want to move forward and aft of the vehicle as load shifts. So they have a support rod on the side of it that moves forward at an angle, and it keeps that control arm from moving back and forth. It's called a strut rod. That strut rod has bushings on it where it goes through the frame member. If those bushings get worn, it would allow that control arm to move back and forth. And that can show up when you make a brake application. So they might come in and they say, well, every time when I step on the brakes, I get this noise or I get this jerk in the front end. So it came in as a brake complaint, but it's not a brake problem at all. It's a problem with the strut rods. So check the tires, check the suspension systems and stuff like that, and make sure you don't have something that is presenting itself as a brake problem that's actually something else. By the same token, if they come in with that problem and you identify these strut rods as being bad, go ahead and do an inspection on the braking system. You certainly don't want to fix these strut rods and then have them actually have a brake problem a couple of weeks down the road. So you might end up going to a customer with something like, hey, the problem that you showed me, the noise that we're into, is because you got bad strut rod bushings. But upon inspecting your brake system, I noticed that your brake pads are getting thin. You have some brake hoses that are starting to show some wear. So we may want to go ahead and do some service work on the brake system at the same time we're replacing these strut rods. You know, if they don't want to do that, that's on them, not on you. But at least you've done your due diligence and you've informed them of the operating condition of the brake system. So once you've identified the cause of the fault, determine the action that will correct the fault. Guys, two things that as a technician that are very important that you learn. The first one is a good diagnostic process, something that every time you come up against a problem, you have a process for diagnosing that problem, and that's your go-to. That's what you do each time. So you develop a good diagnostic process. And the next thing you need to develop is a set of standards, personal standards that you won't compromise. I don't want to be the type of mechanic that, hey, I'm the guy down the road that does it cheaper. I don't do very good work, but I'll do it cheap. So if you want something done cheap, go down there and see Steve. I'm not interested in that. I would rather do the kind of work that I can be proud of, that when I ship it down the road, I can think that that customer is leaving here with something that's going to be safe and reliable. They probably spent more money, but that's what that's what the business is about, is making money. And it's not ripping anybody off or anything. It's just doing quality work. And so I use good quality parts. I use name brand stuff. And I've got standards I won't compromise. I will not put a brake rotor on that's undersized, or even, when it starts getting pretty close, I start getting a little leery of it. Brake hoses. I have standards about brake hoses. If they have any cracks or any distress at all in the brake hose, I want to replace that. And if they don't want that type of work done, there's a lot of other shops that will do what I consider to be substandard work. But develop a good diagnostic process, and develop a set of standards, and just lean on those each day as you go to work. And it gets to be once it gets to be habit, then you don't even think about it. You just do it. Some of the tools that we're going to use when we're working on these brake systems: brake lining thickness gauges, which is something that I very rarely use. I look at a set of brake pads and think, yeah, they need to be replaced, or no, they don't. But they make thickness gauges you can use. A brake wash station, which is very important. Again, you don't want any of these brake dust or stuff. You don't want any of that airborne, and a brake wash station prevents that from happening. Brake caliper pliers, micrometers, dial indicators, brake cable pliers, caliper retracting tool, and we'll see that here in a minute. That's for that one that uses the piston that extends and comes back to clamp the brake pads for a park brake. And then a C-clamp, an on-car and off-the-car brake lathe, which we've used already in lab, and a set of drivers for the seals. Here's these wear thickness gauges. You can just compare that to the brake pad thickness. And to me, if I look at a brake pad and it's somewhere in here, it's good. And if it's starting to get down here, it needs to be replaced. I don't worry too much about these. Here's one of the brake wash stations. Again, it will liquid will cause this brake dust and stuff to come off without getting exposed to the atmosphere, where you can breathe it or inhale it, and that's what you want. You don't want that to happen. Here's a micrometer that's designed for brake rotors. Notice the depth of the mic here, where you can get it over a brake rotor. Here's some brake caliper pliers that you use for several different things on the brake calipers. Here's a dial indicator, again, that's going to measure a run out. This style is a little different than the one I bought to class the other day. This has vice grips you can clamp onto about anything, and then it has a flexible shaft here. And when you turn this lever, this shaft is no longer flexible; it's rigid. So you can position this just about anywhere you want to, and then lock this down, and you have your dial indicator mounted. It makes it really nice. This tool is for working on park brake cables. Here's one of these integrated calipers for the park brake, and notice the little lugs that's in this piston. Remember, I said this piston is two-piece and it kind of threads against itself. When you can't push these back in with a C-clamp, you'll damage it. You have to use a tool like this that has these little lugs that will engage these, and this has to be turned as it's pushed back in. If you don't do it that way, it will damage that. But that tool is almost mandatory if you're going to do these type of brakes. And here, of course, is our two brake machines. And here's a set of drivers for seals. And I really suggest that you buy a set of these. They're not expensive. I bought a really nice set of these several years ago at Harbor Freight for about 25 bucks. I use them all the time for different drivers for different things, but putting seals in mainly is what they're good for. And to put a seal in with one of these and not damage it sure beats trying to find a socket that's the right size or something like that to put those in. So buy a good set of seal drivers and then use them. Common brake concerns. Again, I told you a lot of your concerns, a lot of stuff you're going to hear about on brakes are going to be noise. You could also get poor stopping, vibration, pulling to one side or another, grabbing, brakes dragging, not wanting to release, or a pulsation, which is a little bit like the vibration thing. So it says that they're easier to diagnose than most other systems. These are just some common brake concerns, different things that you're gonna hear about. So if we're gonna put a set of pads on one, guys, a lot of times with brake pads, if somebody comes to me, and I don't do work for other people very much anymore, very, very seldom. But if somebody come to me and they just want a set of brake pads put on their car because their brake pads are worn, I'm going to do an inspection as I'm doing that. But if the rotors look good and they measure okay, and the brake hoses look good, the calipers don't show any signs of distress, then I can put a set of brake pads on that thing and have it back together and nothing flat. It doesn't cost a whole lot of, won't cost them a whole lot of money. But if if I start to see brake hoses that are bad and calipers that are showing some problems and maybe some grooves on the rotors, then it's going to get far more involved. It says to research the procedure for removing the caliper, loosen the bleeder screw slightly and then retighten it. Here's the bleeder screw. And what they're doing is they're just loosening this bleeder screw and then tightening it back up. Reason for that is if you go do a bunch of work on these brakes and stuff, and then you go to bleed the brakes and you twist off this bleeder screw because it wouldn't come loose, then you've done a whole lot of work for nothing, because my experience has been those things are tough to get out of there when they twist off. And there's a good chance you won't get it out and you have to replace the caliper. So save yourself that. If you're trying to take these loose at the beginning and you twist it off, it's no big deal. You're going to replace the caliper. So anyway, it's a good idea to check those bleeder screws before you get too involved in this. So if the caliper is being rebuilt or a new caliper will be installed, it's good practice to flush the old brake fluid from the system at this time. What they're doing here is they're using a pedal holding tool, and it says it blocks off the compensating ports to avoid the excess fluid leakage. So if you do this, it'll stop that drip, 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 drip as you're working on the brakes. Remove the caliper, brake line, or hose from the caliper. Be sure not to lose the sealing rings. Guys, we know on this banjo type fitting that if we have these copper fittings or washers here, we're going to replace those every time. It says here, push the pistons back into their bores slightly. Though many mechanics use a screwdriver as shown, a pry bar or C-clamp is a safer choice. If you can get between this caliper and the brake pad and push that brake pad back in, which is basically pushing the piston in, be very careful doing that. These phenolic pistons, these plastic pistons, if you happen to get against that piston, it'll chip the end off of it, and you'd have to go in and replace that piston. Which, if you do the math on dollars, it's cheaper to replace the caliper than it is to replace the piston almost. So be very careful doing that, but you need to push the pads in a little bit so that the caliper will come off. When you do that, you have everything loose, the caliper will come off pretty easily. Again, make sure that when you take this caliper off, you have some way to support the caliper. You can't let it hang by the rubber hose. You don't want to stress that rubber hose in any way. So a lot of times I just use wire ties, zip ties, and zip tie it to a control arm or spring or something like that. Just anything to keep from stretching that hose. At this point, we're going to inspect the caliper. One area for inspection is this boot around the outside. This seals and keeps water and dirt and stuff from getting in alongside this piston. And remember, this thing has a lot of cycles, hot and cold, hot and cold, hot and cold. It's hard on that rubber, and that rubber will get hard. And when it does, it's liable to crack. And when it does, that caliper is destined to fail in a pretty short period of time. It says here we're cleaning the mountings and pins using the brake wash station here. Again, I like brake clean. I spray everything down with brake clean. Brake clean is not terribly expensive, and I like it because it's quick and easy. You can put a trash can under it and catch the residue. And when it dries very quickly. It evaporates quickly, and it doesn't leave any residue or anything. So I use a lot of brake clean. It says once the dust is taken care of, you may need to use brake cleaning solvent to clean the components further. Here's some of the slides for a floating or a sliding type of a caliper, and these obviously need some attention. Here's one that looks pretty good. Make sure you keep those all cleaned up. Some of them require a lubricant that's put on those. It's a special grease that's made just for that. But anyway, check the application, see what needs to be on there, and then service those up. Those slides need to work very well. Determine the type of wear indicator and check that it's not contacting or nearly contacting the rotor. You see, here's your little wear indicator right here. See, it's quite a ways from the rotor. This has still got quite a bit of brake pad left on it. I I would not condemn these brake pads here at all. I would tell the customer on these that they've got quite a ways to go before those need to be replaced. If the brake system is a sensor style, the one that turns, here's what the light on the dash is going to look like, by the way. But if it's the sensor style, to test that system, again, you turn the key on and you're going to ground the contact out here. And if the light comes on, then the system is working. The warning indicator is working. Remove the brake hardware and retaining the brake pads and retaining hardware. Again, here are some of these little clips that support the brake pads and keep them tight in the calipers. Replace those when you get them new. They, like I say, they send them with the pads generally. Just put the new ones in there. And here they're measuring the rotor thickness. And if you can't look at that, or pad thickness, if you can't look at that pad and tell that pad needs to be replaced without that little plastic tool, then you probably need to be doing something else. Disassemble the caliper following the service procedure. And here what they're doing is, notice they've got a block of wood here, and they're using a rubber tipped air nozzle and putting it here where the brake hose goes on, and that will push this piston out so that you can clean it up and service it. And here's one of them apart. Here's the caliper. Here's the sliding pins, or floating, whatever you're going to call floating pins, I guess. Here's the phenolic piston. Here's your square cut O-ring that sits on the inside, and here's your dust boot that sits here on the outside. So if we were going to at this point rebuild this, we'd make sure these bushings are good here. These little rubber bushings that seal the ends of these brake slides. If they're good, make sure the inside of this bore is clean, free of any damage or nicks or anything like that. And we can put our seal in, lubricate our piston and push our piston in. And then our dust boot's going to go on the top, and we'll have a driver usually that drives that in, and that would be our caliper. It says inspect each of the parts for damage, rust, and wear. Also check the caliper pin bores or bushings for wear or damage. Replace if they can't be cleaned up. Guys, I don't again rebuild many of these. For me, it's just not very cost effective to rebuild them. It's far simpler just to take them off and put them in a box and take them to the parts store and exchange them. I've rebuilt a lot of brake calipers. I don't mind doing it, but it's just not very cost effective to do it. There's not a lot of money to be made. Here, they're measuring the caliper to bore clearance with a feeler gauge and compare to specs. Again, time is money. I mean, do you really want to do all this when the difference between a rebuilt caliper and one that you rebuild is minimal? You know, labor is $100 an hour now. How much time are you going to spend rebuilding one of these calipers? A lot of people do, and that's fine, but that's not my bag there. Reassembling calipers. Make sure that the rotor's been properly installed on the hub and that the hub surface is free of dust and dirt. Remember we talked about cleaning all this up where that sits flush up against it. Install the piston seal using brake fluid or brake assembly fluid. Guys, remember, brake fluid is what you use as a lubricant on brake systems. If it uses brake fluid inside it, that's what you're going to use to lubricate it. You can't use, you know, regular grease or any petroleum product or motor oil or anything like that inside these calipers. If you do, it's going to destroy the rubber components in just a short period of time. So use brake fluid to lubricate those. It says here brake assembly fluid. I've never heard of that, but if they make that, I mean, if it's acceptable, that's fine. I always just use brake fluid to lubricate that stuff. It says install the piston by hand, careful not to pinch, twist, or cut the sealing ring and dust boot. Usually, if you've got that lubricated properly, that bore of that caliper and that O-ring lubricated well, put a little bit of brake fluid on the piston itself, you can usually take your thumbs and just work it right down into place. Now here they've got the dust boot already set on the groove so that when they get it in there, they just have to drive it into its housing and it's done. This is assemble the pads, hardware, and caliper on the caliper mountings using the specified lubricant. Lubricate all moving parts. Now, guys, this is a special lubricant. This isn't just axle grease or chassis grease or something like that. This is a special brake lubricant, and that's what you need to use on these. It says reinstall the brake line and fitting using 2 new copper washers This is a banjo fitting, and you would use new washers on that. I tighten the fitting and to the proper torque, bleed the brakes, follow the manufacturer's procedure on that. Seat the pads by applying the brake pedal several times, not allowing the pedal to go to the floor. Guys, remember, after you work on disc brakes, those pads are away from the rotor. So when you step on the brakes, that pedal is going to go all the way to the floor. Be sure when you're through working on disc brakes, the first thing that you do is go in there and slightly pump that pedal until you get a good solid brake pedal. So get those pistons pushed out and get those pads pushed up against the rotor. Otherwise, you're going to have an accident when you leave because you're going to have your brakes. They said if the brake pedal is spongy, you need to bleed the brakes of any remaining air trapped in the system. So we've gone through and we know how to do that. And inspect the system for any leaks, no matter how small. So if those were there, you would have to you'd have to deal with those. And with that, I'm going to shut this down for tonight. We'll pick back up, and we're gonna go on Monday. I think we're going to go to the lab pretty early on. Probably won't have nearly as much lecture on Monday, but I will see you all then. Thank you very much for watching. I hope this was helpful.